There is magnetic field due to a current. Now we know that if there is any current in a conductor, the conductor might be finite or infinite or any arbitrary shape. Close to the conductor at any point, any magnetic field is developed. The magnetic field intensity, it is given by initially the Laplace law. But the direction of magnetic field later on given by Biot-Savart law, for which it is now known as Biot-Savart law. Now what is magnetic field or magnetic field intensity? Basically, if we place a unit north pole in the field, what is the force exerted on that north pole? The magnetic field intensity unit is, in SI unit Tesla, and in CGS unit it is Gauss. 1 Tesla means 1 Weber per meter square. Weber is the unit of magnetic flux, and 1 Gauss is 1 Maxwell per cm square, where Maxwell is the unit of magnetic flux in series system. The conversion of Tesla to Gauss is 1 Tesla equal to 10 to the power 4 Gauss, and conversion of Maxwell to Weber, 1 Weber equal to 10 to the power 8 Maxwell. Now let us understand the Biot-Savart law. In Biot-Savart law, the magnetic field intensity for any current carrying element of length dl at a distance of r is given by vector dB is equal to mu naught by 4 pi I dl cross r, vector dl cross vector r divided by bond r cube. The vector dl is taken along the direction of the current, where dl is a very small element. Mu naught is the permittivity of free space. The mu naught, the value of mu naught is 4 pi 10 to the minus 7 in SI unit, and in CGS unit mu naught equal to 4 pi. Now, if we try to find out the magnetic field, we have to integrate. That is, integral dB is equal to mu naught I by 4 pi integral dl cross r by mod r cube. That is, ultimately will come mu naught by 4 pi I sin theta dl by r square. Now the direction of the field is given by dl cross r. Now if the current is clockwise about the point where we are trying to find out the magnetic field, it will be downward going in, and if the current is clockwise, anti-clockwise, it will be outward, coming out. That means if we take the right hand rule, if we curl the fingers of right hand, if the direction of the current gives the fingers the upward, that is, the thumb will give us the direction of the magnetic field. Now the magnetic field we can find out for a circular wire or a rectangular wire or a finite or infinite wire or any shaped wire. For your reference, you just go to the text of S. Verma or any other text and go to the textbook, for which after listening the lecture very carefully you can understand the topic. Now for any circular wire of radius r, suppose the current is I of radius r, there is a magnetic field at the center is given by mu naught I by 2r. Mu naught I by 2r. That means if the current is clockwise about the center, the field is cross. Cross means going down. And if the current is anti-clockwise, the field is coming up. That is dot. That means cross is given the direction the downward, and dot gives the direction the upward. Similarly, If we take any wire, straight wire of finite length, suppose if the current is carrying I, and at the point P, if we try to find out the magnetic field at any point, and if the angle, the vector with the wire PA and PB, where AB is the wire, makes an angle PAB and PBA is suppose theta 1 and theta 2. In that case, the magnetic field is given by mu naught I by 4 pi a cos theta 1 plus cos theta 2, where a is the distance of the wire from the point P. If we take any segment of a circle, suppose part of a circle, it might be half of a circle or quarter of a circle, in that case magnetic field will be mu naught I by 2r into theta by 2 pi, where theta is the angle subtended at the center. Just for example, for a semicircle, it will be just half of mu naught I by 2r. If it is a quarter circle, that is 1/4 of a circle, that is mu naught I by 2r into 1/4. Suppose if we take an arc of 30 degree, that means it will be mu naught I by 2r into 30 degree means pi by 6 divided by 2 pi. Ultimately that is 1/12 of this part. To find the magnetic field for a given square of suppose side A and carrying a current I at the center, in that case the distance of the wire from the point P is A by 2, angle of any segment or any side AB that makes with the center angle OAB or OBA, that is 45 degree. In that case, we try to find out the magnetic field for one side, mu naught I by 4 pi into A by 2 sin 45 cos 45 plus cos 45, and this whole multiplied by 4 times, as because in a square there are 4 sides. In case of a rectangle, you have to use the same concept, but the sides are given A and B. In that case, for 2 sides the distance will be B by 2, and for the other 2 sides the distance will be A by 2, and angle for the 2 sides will be identical, and for the other 2 sides the angle will be identical, but the angle is not 45 degree for a rectangle. So dear students, just go through the lecture very carefully, and in the next class I will discuss about the problems, and we will send you some problems, solve problems as well as some assignment for the next class. Okay.